What are we doing explicitly for this week's lab? As I've said before, you're measuring the melting points of benzoic acid, mandelic acid, as well as mixtures of these compounds. In the chart on the slide right now, you see the melting point information for both benzoic and mandelic acid, and you can see that it's in a similar range. Likewise, you're going to be analyzing mixtures of these compounds. The mixtures are already pre-made. They may be labeled mixtures 1, 2, 3, and 4, and if so, these are the compositions. However, HAREL tends to traditionally label what the percent ratio is. So you may see labels on the mixtures with 80-20 or 8-2 or 4-1. And all of those would be describing mixture 1. You're going to measure the melting point of these 4 mixtures, and using all of the data collected from the information on this slide, you'll make that melting point mass percent composition diagram that we had looked at earlier for our theoretical compound X and compound Y, and be able to estimate a eutectic temperature and eutectic composition for benzoic acid and mandelic acid. If you don't actually get a point where those two lines intersect in kind of that V nature that we saw earlier, you can postulate and sketch out what the trajectory of your actual lines would be. And you can do this, of course, using Excel and some line mapping formulations. The second part of the lab is using the mixture melting point technique to identify an unknown. You will be assigned an unknown by your TA, and this list that you see on the screen is all of the compounds that your unknown could be. So you will refer back to table 1. Again, this can be found in your lab book, and it's also here in the slides, so that you could correctly identify 2 potential compounds that your unknown might be and use those in the mixture melting point. Briefly, to remind you of the procedure, grind up the benzoic acid and mandelic acid. You need very little for each sample, so you don't have to worry about getting out large amounts. Typically, this is something that's eyeballed. Your lab book might give you an actual mass to weigh out, and that's fine. But generally, just kind of the end of your spatula will be enough for a melting point sample. And as I've said in the past, I suggest grinding on a watch glass instead of in the mortar and pestle to avoid sample loss and sample contamination later in the lab in case you don't get the mortar and pestle that's white cleaned from all the white solid. Again, your mixtures are already going to be mixed up, and I have kind of that reminder of how HAREL could label it 80-20, talking about percentages. That could also be an 8-2 ratio, or even reduced down to a 4-1 ratio. Keep an open mind for interpreting this information. It all is the same information. It's just perhaps written in a way that you didn't anticipate at first. Don't let this fluster you. Once you have completed all your benzoic and mandelic acid data collection, then talk to the instructor in your lab to get assigned an unknown. You're going to first take a rapid rate melting point to get an idea of the range so that you can then identify 2 unknowns from our table that we just looked at that could potentially be your unknown. You're going to get a small sample of each of those compounds and mix equal portions, 50-50, of your unknown with each sample, okay? That means you're going to have 2 mixtures, one being 50-50, your unknown, and one of your potential unknowns, and another one 50-50 with your unknown, and your second option, your second potential identification of your unknown. Again, make sure to grind up the samples pretty well prior to packing. Once you have created your mixture samples, then you're going to take slow melting points of both mixtures, so that slow rate as you get close to your anticipating melting point, as well as you're also going to analyze via the slow rate a pure sample of your unknown, kind of as a control to verify the melting point of your unknown. And then you'll make the comparisons to determine which one of those compounds is actually your unknown. Things to remember: if a sample melts immediately when you put it into the melt temp or into the melting point apparatus, you need to lower your starting temperature. Mixtures, again, will be at least 10 or 15 degrees below the anticipated melting point. So for example, if I thought my compound was benzhydrol, then I would probably set my temperature to start at 50 in order to look at a mixture of benzhydrol with an unknown compound. Finally, once you've collected all of your data, but prior to coming to lab the next week, you will share your data and answer the questions that will be asked of you in Moodle. We're no longer handing out physical worksheets in the lab. All of that will be logged via Moodle. You will be asked to write a short summary / conclusion, and of course, we'll need a proper identification of your unknown, as well as the graph that's been mentioned before. Good luck.